So for problem 6, we're looking at solving an equation and then rounding to the nearest hundredth if necessary. If you look at 6a, b, and c, they're all very similar. So the process of like finding the common denominator is going to be the same. So that piece of it will be the same for each of them. And then the way that we come up with the answer and the way the answer looks will change within each of these. So for a, we have 5x minus 3 over x squared plus 6x plus 8 equals 1 over x plus 2 times x plus 4. So what we need to do is factor the x squared plus 6x plus 8. So I need two factors, numbers that multiply to positive 8 and that to 6. And so that's going to be 4 and 2. So this factors to x plus 4 times x plus 2. And so because of that, all of these are going to factor to that as well. And so remember that when we're solving an equation, we want to start by identifying the domain so that we can determine if something is extraneous. And so the domain of this function is going to be all real numbers except for the values that will make this 0. So I'm just going to list out what x cannot be. So x plus 4, if I set that equal to 0 and solve, x can't be negative 4. And then x plus 2 means that x cannot be negative 2. And so then these denominators are actually the same. And so that means that if I get an answer of negative 4 or negative 2, that I actually have no solution because this problem will create an undefined solution. So the process for solving an equation is that we multiply by the least common denominator. So we multiply all the numerators by the LCD to cancel them out. And so since these two have a denominator that includes an x plus 4, that times x plus 2 is going to be the least common denominator. So really the denominator of the first fraction is the common denominator. So x plus 4 times x plus 2 is the LCD. So what I'm going to do is rewrite this equation with room to multiply the numerators of every fraction, so the numerators of every term, by the common denominator. So I have x plus 4 times x plus 2. And I'm going to multiply each of these by the LCD, right? So I'm going to multiply that by the LCD, I'm going to multiply that by the LCD, I'm going to multiply that by the LCD. So I'm multiplying the whole equation by the least common denominator. So it's going to just multiply in the numerator. So I have x plus 4 times x plus 2 here equals my next fraction, which is 1 over x plus 2 times x plus 4 times x plus 2 plus 1 over x plus 4 times my common denominator of x plus 4 times x plus 2. Remember that the purpose of this is so that the denominators reduce away. So I'm multiplying by the LCD so that all of the denominators reduce. So for the first fraction, all that I'm left with is 5x minus 3. For the second one, I have a, whoops, sorry, I want a different color than blue. I have an x plus 2 in my denominator, so I can reduce that with the x plus 4. So I'm left with 1 times x plus 4, which is just x plus 4. And finally, the last fraction has a denominator of x plus 4, so that's going to reduce with the x plus 4 in our LCD. And then, so plus I have 1 times x plus 2, so that's going to be plus x plus 2. And so now I have this equation that is actually linear that makes this a lot easier to solve. So I've gotten rid of the denominators, so I want to combine like terms. So I have 5x minus 3 equals 2x plus 6. To solve for x, I want to subtract 2x from both sides. And I want to add 3 to both sides. So if I subtract 2x and I add 3, that's going to give me 3x equals 9. So if I divide by 3, that tells me that x is 3. So remember, I'm always checking with my domain. And so since that is not one of the excluded values, that's not a value that would make my denominator 0, that means that this equation has a solution of x equals 3. Okay, so I went through and rewrote what we looked at the beginning of part A for B and C. So remember that if you look at the denominators, they're all the same. So the only thing that changed within these problems is that first numerator. So the domain is going to be the same, that x can't be -4 or -2 because the denominators all factor to x plus 2 times x plus 4. And so what we're going to do is that same process, but our result's going to look a little bit different. So remember that after we look at our common denominator, we're going to multiply everything by the common denominator. So just like if I was like dividing the whole equation by 3, right? I would multiply by x plus 4 times x plus 2 in hopes or with the result of the denominators canceling because it all reduces. So I've got x plus 4 times x plus 2 that I'm multiplying each numerator by. And so for the first expression, I have both factors in my denominator, so they're going to reduce to away. So I'm left with just my numerator, 2x plus 6. So that's going to be equal to, for the second fraction, I can reduce x plus 2's. So that's going to be 1 times x plus 4. So just x plus 4. And finally, I can reduce x plus 4 for the second one. So I'm left with plus 1 times x plus 2. So just plus x plus 2. So if I combine like terms to simplify, the left-hand side of this is 2x plus 6, and the right-hand side simplifies to 2x plus 6. Notice that these are exactly the same. So what that means is that this is an all real numbers answer. However, remember that in our domain, we are restricted for x. So that means that the answer is all real numbers except -4 and -2. Okay, so this one, I got the same result on both sides of the equation. So 2x plus 6 is going to equal 2x plus 6 no matter what, because it's literally the same on each side. That means that we have an infinite solutions answer. So any x that I plug in is going to give a true statement for 2x plus 6 plus equals 2x plus 6. However, -4 and -2 is going to be undefined for the original problem, which eventually results in 2x plus 6. So all real numbers except for -4 and -2 is the solution to this problem. So if we look at C, again, it's the same problem, except that numerator has changed so that it's 2x minus 6 this time. And so it still has a domain of x can't be -4, -2, so we still need to check our result with that. And then we want to multiply the numerators by, or the whole equation by the least common denominator, which is x plus 4 times x plus 2. So as I do that, we're looking for reducing out each denominator. That's why we're using the common denominator, so we know that we'll catch everything. So for the first fraction, we've got x plus 4 that reduces and x plus 2 that reduces. So we're left with 2x minus 6. That's going to be equal to, for the second fraction, x plus 2 reduces. So 1 times x plus 4 is just x plus 4. And finally, if I add the last one, x plus 4 reduces with x plus 4. So I've got 1 times x plus 2, so plus x plus 2. So looking at this, if I combine like terms, I've got 2x minus 6 equals 2x plus 6. So notice that it's almost the same, but it's not quite. So what will happen if I try to move the x over is I get x's canceling on both sides. So I get the statement -6 equals 6. Since that is a false statement, that means that this actually has no solution. So since I had 2x on either side, and then I was adding or subtracting something different, that's a clue that this problem has no solution. The next solving equations problem is different in the sense that not everything has a denominator, and the denominators aren't quadratics that I can factor. So I'm going to use the same strategy. My LCD is just going to be a little bit different. So I've got 8 over 5x minus 2 over 9x equals 7. Remember, whenever we're subtracting, just to keep our work organized and make sure we don't lose that negative, we want to turn it into adding a -2 on top. So if I look at my denominators, my least common denominator, since they both have an x, is going to involve that x times, this is 5 times x, so x times 5, and 9 times x. So that means that my least common denominator is going to be 45x. That means that since I have an x in the denominator, if I take my common denominator and look at the restriction, that tells me that for my domain, x just can't be 0, because 45 times 0 is 0, 5 times 0 is 0, 9 times 0 is 0. So I'm going to take and multiply the numerator of each one by my LCD, which is 45x. And so when I do that, the x's cancel out or reduce on the numerator. So 45x divided by 5x is going to give me 9. So I'm going to have 8 times 9, or 72. For the next term, I've got a 9x in the denominator. So 45x divided by 9x is going to give me 5. So I have -2 times 5, or -10. And then for the other side of the equation, I don't have any denominator, so there's no reducing. I'm just multiplying 7 times 45x, which is 315x. Whoops. And so 72 minus 10 equals 315x. If I combine like terms over here, that's 62 equals 315x. So if I divide both sides by 315, x is 62 over 315, which is about 0.20 if I round it to the nearest hundredth, as it said in the directions. Part E, we have a word problem, so we have to create our equation ourselves. This is a work problem where it's asking if they work together. When we see that, that means we're going to use it equal to 1 because the job is 100% done. And we're going to write a fraction to represent each person. So it takes 14 minutes for Susie to clean the kitchen. Oops, that didn't change colors. It takes, excuse me, 14 minutes for Susie to clean the kitchen. So if they're working together, Susie's gonna do, we're gonna take X minutes over 14 to determine how long they're gonna work together. So we're taking the time divided by her rate, which is 14. Plus Mark takes 8 minutes. So we're gonna take X divided by his rate, so 8 minutes, to figure out how long it's gonna take them if they work together. So X over 14 plus X over 8 has to equal 1. When we're looking at this, we want to identify the least common denominator. So if we think about 14, 14 is 2 times 7, and 8 is 2 times 4. So my LCD is gonna be 2 times 7 times 4. I'm not just going to multiply 14 and 8 together because I know they're both even, so they're going to have a common factor. And so that's 56. So my LCD is 56. So I'm going to multiply everything by 56. To get my result. So if I reduce 56 by 14, that's going to give me 4x. If I divide 56 by 8, that's going to give me plus 7x equals 56. I can't read my own writing. Equals 56. And so then that's going to give me 4x plus 7x is 11x equals 56. And so then we have to divide the 56 by 11. So we've got to take and divide both sides by 11. And so x equals about 5.09 minutes. So it'll take them about 5 minutes to complete the task together. Question 7 is a graph of y equals x plus 1 over 2x minus 2. And so when I'm sketching a graph, I always want to factor any piece of the function so that I can look at things for the asymptotes. So if I look at my denominator, it factors to 2 times x minus 1. So the original form of the equation tells me what the horizontal asymptotes are. And so remember the rules of the horizontal asymptote is I'm looking at the degree. So these are both linear functions, x plus 1 and 2x minus 2. Since they're linear, they have the same degree. So that means I'm going to take the ratio of the leading coefficients. The coefficient on x in the numerator is 1. The coefficient on x in the denominator is 2. So that means that our horizontal asymptote is that y equals 1/2. So let's draw that line in. At 1/2. Then we want to identify the vertical asymptotes and the holes. So remember that I have a hole if something reduces. So in this expression, x plus 1 does not reduce with x minus 1. So that means that there is no hole in this graph. There's just a vertical asymptote. So the vertical asymptote occurs when the denominator is 0. And so since I have a 2, that's never going to be 0. However, x minus 1 will be 0 when x equals 1. The vertical asymptote's at x equals 1, so I want to draw in a vertical line at x equals 1. So when I create my table, I'm looking at that value of 1 and picking two numbers on the left side of 1. So those two numbers on the left would be 0 and -1. And then two numbers on the right, which would be 2 and 3. So those are the values that I'm going to plug into the equation to determine the y's. So when I plug in -1, I'm looking at -1 plus 1 over 2 times -1 minus 2. So that's going to give me 0 over -3, which means that the y value at -1 is 0. Next, I'm going to plug in 0, so that's going to give me 0 plus 1 over 2 times 0 minus 2. So that's going to give me 1 over -2, so that y value is -1/2. So at 0, I'm going to be at -1/2. So this means that my graph is going to be a curve in the bottom left corner between the two asymptotes. Next, I want to plug 2 into the original equation. So I've got 2 plus 1 over 2 times 2 minus 2. So that's 3 over 4 minus 2. So that's about 1.5 for my y value. So 2 and then 1.5 is up here. And then when I plug in 3 plus 1 over 2 times 3 minus 2 is 4 over 6 minus 2 is 4, so that's 1. So the y coordinate at 3 is 1. So that's going to be in the top right quadrant between my two asymptotes. So that graph did not have a hole. It had a single vertical asymptote. Our next graph is an x plus 3 over x squared plus 5x plus 6. So if I look at that, the degrees are different. So my numerator is linear, which has a degree of 1. My denominator is quadratic, which has a degree of 2. So since the degree of the denominator is larger, that tells us the horizontal asymptote is at y equals 0. So our horizontal asymptote is our x-axis. We need to factor the denominator to determine if there are any holes and vertical asymptotes. So if I have x squared plus 5x plus 6, two numbers that multiply to 6 and add to 5 are x plus 3 and x plus 2. So because this simplifies, I have an x plus 3 in the numerator that will reduce with the x plus 3 in the denominator. I want to think about this as 1 over x plus 2 instead. So since this reduced at x plus 3, that tells me that my hole is going to have an x coordinate of -3. So -3 is going to be a hole rather than a vertical asymptote. And then the denominator that's left over is x plus 2. And so that means that our vertical asymptote is going to be at x equals -2. Okay, so our vertical asymptote's at x equals -2. Remember that no matter what, we want to plug in our hole so that we can figure out what the y value is and graph it appropriately. So -3 would be in our table anyway, so it's right to the left of our vertical asymptote. And then we want to also pick another number on the left side of -2, which would be -4. Then we want to pick two numbers to the right of -2, which would be 1 and 0. So we're going to plug in -4, -3, which is also our hole, and then 1 and 0 into our reduced equation. So whenever you can reduce something, you have to plug it in for the hole, but it's a lot easier to plug it in for all the values. So these are equivalent. So if I plug -4 into 1 over -4 plus 2, that's going to give us a y value of -1/2. So we're going to plot the point -4, -1/2. Then we want to plug in -3. So 1 over -3 plus 2 is going to give us a denominator of -1. And so 1 over -1 is -1. So that means our graph has a hole at -1. 3, -1. So if I connect and draw those points, this graph looks like this in the bottom left quadrant. Then we need to plug in 1 and 0. So 1 over 1 plus 2 is 1/3. So we're going to plot the point. Oh, I was supposed to plug in -1. That's okay. +1 1/3 would be here. And then if I plug in 0, I get 1 over 0 plus 2, which is 1/2. Since I skipped it, and I'm sure some of you had already done this and plugged in those values, let's plug in -1 because that's what I should have written for that value. If I plug in -1, 1 over -1 plus 2 is 1 over 1. So that's going to give you a positive 1 for that value. So in that, I graphed these wrong. So it's going to give you a +1 for that value. So -1 is +1. 0 is -1/2. And then the 1 is +1/3 that I accidentally graphed as a -1/3. So that means that this graph would look like this on the top right side. Okay, so remember that if it reduces, you then have a hole at the value that would make that denominator and numerator 0. So a hole occurs when the numerator and denominator is 0. So since 0 would make the numerator and -3 would make the numerator and denominator 0, that's the location of the hole. So that's all for the review for this test. So make sure that you're studying each of those problems and understand them for the test on Friday.